In this section, we see how the sign of the derivative f prime may be used to determine where a function f is increasing and where it is decreasing. This information will enable us to classify the local extrema of the function. In recap from our last section, we learned that if f prime is positive or greater than 0, then the function f is increasing on that interval. Conversely, if f prime is negative or less than 0, then f prime is decreasing on that interval. We can use this information to solve and graph functions. Now, what we do, take the function f of x equals x cubed plus x squared minus 5x minus 5. The first step in finding where f is increasing and decreasing is obviously to find the derivative. So we take the derivative of the function, and to make things easier on us in the future, we will just factor it. And now we can evaluate it and find where it is equal to 0, because where it is equal to 0 or fails to exist are our critical points, if you recall from the last section. This would be at x equals 1 and at x equals negative 5/3. Now, knowing this and our zeros, we need to create a number line. We must then place our critical points on the number line. Not have to be very specific, just generally where they would fall. Negative 5/3 being greater or less than 1. That does not look like a 5. Now, we evaluate points between negative 5/3 and 1, and points that would be greater than 1, and then points less than negative 5/3, basically the whole stretch of the number line. To do this, we take a value in between there, let's say 0 for this number, and plug it in both sides. We find that 0 when plugged into here gives us a positive, and 0 when plugged into here gives us a negative. Negative times a positive number is a negative number, so we mark this as a negative section. We do the same for the other two sides. Let's take 2 on this side, plug that in, and we find that this is positive, and so is this. Therefore, this is positive, and we mark it as such. Let's take negative 2 on this side, and we find that this is negative and then negative. Therefore, this is positive. Now that we have our number line all done, we can recall that when f prime of x is negative, it is decreasing, and when f prime of x is positive, it is increasing. Therefore, we can conclude that the function f is increasing on the interval from negative infinity to negative 5/3. It is decreasing on the interval from negative 5/3 to 1, and then increasing again on the interval from 1 to infinity. Now, you may be asked to graph. Knowing what we know, we must plot again our critical points, 1, and then negative 5/3. And then we know that from the previous slide is negative in between negative 5/3 and 1. Therefore, it is falling, means its slope is negative. We don't have any specific points, so we can just go ahead and draw a falling line between the two. But however, we know at 1 it switches and becomes positive again, and we know at negative 5/3 it becomes positive. Therefore, the graph could look something like this. The graph has local extrema here and here. We also use the first derivative test to help us classify these. We see that if the slope switches, here we have a maximum where it switches from positive to negative, and here a minimum going from negative to positive. From positive to negative, then f of c is a maximum, and if it switches from negative to positive, f of c is a minimum. Here are some examples. These are both minimums as the slope goes from negative to positive. This is also a minimum going from negative to positive.